Here's a statement that won't surprise any of us. Your data is continuing to grow. Now, while we can all agree with that, and we can understand the market dynamics and what's causing the data within our environments to continue to grow, and grow at very fast rates, the real devil in the details is why, and what type of data is growing. If you're like many customers out there, you've started to dig into this. You've started to realize that much of that data growth is unstructured data. In fact, analysts all say that unstructured data is growing 3 times the speed of structured data within your environment. And yet, we continue to try to store, secure, and solve the unstructured data management challenges the same way we have for the last 20 years. My name's Don Foster. I'm the global head of Panzura's field sales engineers. And we're going to discuss today how Panzura can help you transform the idea that you have behind your unstructured data management and provide you the mobility, the access, the security, and the control, all through a single global file system that's cloud native that will help you unlock that next round of business innovation. We do this through our flagship product called CloudFS. CloudFS essentially gives you an authoritative store for your data in the cloud while providing fast access and caching nodes to your users and business processes at the edge to provide access, the security control, and performance that you desire. So let's jump straight into how CloudFS works. First, you need to have the authoritative store within an S3 bucket, somewhere either on-prem or in the cloud. Now again, this could be any on-premises S3 solutions that you may choose, or you could leverage any of the commercially available cloud solutions like Google, AWS, Azure, etc. to house this information. What this S3 backend does for you is it provides buckets that store the data payload and the metadata for the entire global file system that's being created. So your metadata is stored in this authoritative store in the backend S3, as well as the payload of all of the buckets, the different versions of those data files, etc. Now, to get access into this S3 in this global file system, we need to provide access nodes to our end users at the edge. Now, what is one of these nodes? A Panzura node, essentially in this scenario, is nothing more than a virtual machine running on the hypervisor of your choice, primarily VMware, but running on a hypervisor with CPU resources, memory resources, and some level of flash-based storage. The amount of storage all really comes up to the size of your global file system, the expected amount of information that you're going to be leveraging. Inside of that storage, it's going to keep 2 key things. First, the metadata to the global file system that's being created. And second, it's going to have a cache. Now, this cache is going to be leveraged to store data as users are writing, but also to help speed the access to any of the information that's been stored inside of that authoritative file store and ensure that the experience to the end users at those locations is as expedient and performant as possible. So essentially, through this node, we now have access to provide updates to the metadata information back into our authoritative S3 store and provide access to our end users into whatever our file system is going to be. So let's talk about exactly what happens when a file gets stored. So let's say we have a user, and let's call this location Dallas. It's where I'm from, it's where I'm recording this, well actually in Fort Worth. But regardless, we're in Dallas and we have a user. And that user wants to go ahead and create a file and store that within, we'll just call it GFS file 1. So GFS being our share name. So when this user creates this file and stores it to GFS called file 1, 2 things happen. First, that file gets written and stored into the cache location, into that Panzura node. When that happens, we run a couple of processes against it. It gets compressed, deduplicated, and encrypted. And as we drive that process, it then also creates information for metadata that aligns back to that file and where it lives in the global file system. Its version, all the different deduplication fragments, etc. Once that process is completed, both the meta information and the information in the cache all now get sent to that S3 repository. The S3 repository takes those Delta updates from what it already has stored. So we're talking about deltas being transferred, and it goes ahead and updates the metadata and updates the actual buckets for the information that are being stored in the backend to ensure that file 1, as was just created by this user, is properly available across the entire global file system. Pretty straightforward and simple. Now, when it comes to truly unlocking the efficiencies of a global file system, it's all about helping to make that data available across multiple sites. So let's imagine then that we have multiple locations then built into this same sort of a setup. We have, say, a Panzura node with storage for metadata and of course cache, and we'll call this one London. And then let's say we also have another Panzura node, again with storage, CPU, memory resourcing, etc., for metadata and cache, and this is in Los Angeles. Essentially what ends up happening is all three of these nodes in different offices all now communicate in what we call a ring. So a ring is multiple nodes running from the same global file system. What essentially now happens is each one of these locations have their own resourcing, their own solid state flash, to drive and store their version and copy of the metadata that they pull and synchronize from that S3 authoritative store, and their own caching mechanism to ensure that they have the hot files or files local to those users always made available to reduce the amount of transition or latency back and forth between the S3 object store, the S3 authoritative store, and those local nodes. So what happens in this multi-user or multi-environment setup, and how does that same file write kind of impact this setup? Well, let's go back to that. User 1 creates file 1. File 1 flows through the same process that we discussed. Deduplicated, compressed, encrypted, etc. Cache, deltas, transferred, and stored centrally. Once that is done, then we have the deltas from that metadata that now also propagates and synchronizes to the local metadata caches at those remote locations. Why is that important? Because as we have file creation happening simultaneously across the entire environment, we want to ensure that users in LA and users in London always have an exact view of what that global file system share should be. So in fact, that metadata update occurs in under 60 seconds, regardless of how many nodes, how many users, and how much data you have stored in this global file system. So that ensures that you can really start to tighten the links between your business processes and the data that it takes to run that next evolution of business innovation, because the data is constantly being updated for that business process or for those users to continue moving forward. But now that leads us to our next question. Great, we have all the information centrally handled in the cloud, deduplicated, encrypted, compressed, it's secure. We're seeing that's a much lower cost because we're using this cheaper form of storage, while caching and providing the experience our end users need. What happens when the same user tries to leverage the same file in multiple different locations? It's the whole version crisis. Well, here's where the beauty of the metadata and the entire control that Panzura offers really differentiates and streamlines what you can do for business innovation. Let's go back to that same file 1 creation. User 1 over here in Dallas is accessing said file. User 2 here in LA wants to also edit and access that file. User 2 goes into the GFS, finds that file, goes ahead and tries to access, and what happens? Well, at this point, this user is currently having this file open and accessible. Could be a Word document, it could be an AutoCAD drawing, it could be a media file, it could be any number of things. As this user is editing and leveraging it, as a part of the metadata of having that information open, we are providing a lock to that file inside the metadata. So what ends up happening as that file opens, that metadata now knows that with this file there's a lock that also traverses across the ring to all the other different nodes, and so everyone is aware of what files are open, what files are locked, and who owns them. So when user 2 tries to access this file, it's going to get a notification. That notification will say you have two options because this file is currently locked. You can either be notified when the lock is no longer persisting on this file, or you can go ahead and download a read-only copy locally. Now, in most cases, people will wait for that lock to go away, but downloading that read-only copy allows them to create yet another version or start another branch of that file while this single source of truth in the authoritative system continues to press forward. When this user decides that they are done with this file and they save it, and all of the updates persist through on the data changes, right? That passes through the cache, it saves, goes to the cache, deltas get stored, metadata updates on all the different locations. At that same point, the lock gets cleared, and that's part of the metadata update process. Now, user 2 can be notified, hey, this file is now available for access. Go ahead and open it, no need to download, and this user now transfers that same locking mechanism locally to their node. That's the beauty of how the locking process and the collaboration process within Panzura's global file system really ensures that you can keep the file integrity, but also improve the efficiency across your users against some of these old technologies we've been using for the last 20 years, all while keeping that one single low cost and secure authoritative file system store in the center in that S3 authoritative store, be it in the cloud or on on-prem S3 infrastructure. Now, all of this sounds pretty cool. The question now probably comes to, great, what happens if one of these nodes has a problem? Great point. From that perspective, Panzura gives a number of different options for availability. The first is something that we would call, and I'll put it right here, a local available node. So a local availability node basically allows us to ensure that this node can speak, again, with meta and cache, it's another VM, can be a failover point for that local access node in LA for, again, this entire global file system. If there's a problem with the virtual machine, for some reason the ESX or the Hyper-V instance goes offline, we have this stored on something different, we can quickly fail over our users to access all of their information from this availability node that's local. Makes it very easy to flip back and forth and keep that level of availability for those users and those business processes. Aside from that, we can also set up what we call a global availability node. And that global availability, in many cases, customers will run as a cloud-native resource. So virtual machine in Azure, AWS, Google, whatever might be native to where you're storing your S3 infrastructure. And this operates just like every other node, metadata and cache and storage, but it can actually fail over for any given site. So if Dallas were to go completely offline, we have a complete site connectivity failure, we can actually fail folks over into the cloud-based setup or to another location setup and reroute traffic for that file system for them there. That ensures constant accessibility, again, into that authoritative file store, metadata, data and updates all occur on the fly. So that gives you availability from a user access perspective and makes it incredibly highly available regardless of what outage or instance issue you might run into. Aside from that, we also give the ability to mirror that S3 instance. So again, cloud to cloud, cloud to on-prem, on-prem to cloud, however you might want to drive this, on-prem to on-prem S3, as long as it's supported by Panzura, we can now give you double the durability and accessibility of those file stores that if we have any issue that occurs in this cloud setup, all of these nodes can now fail over to that cloud mirrored location, providing even availability for the actual back-end process that drives your global file system. This is how we make it available across whatever your needs and goals are for your users. The final piece, of course, to think about is, well, what about file level recoveries? Ransomware is rampant. How do I do fast recoveries of my file data? Well, built into the metadata, we also give you an option to set schedule routines for how frequently you want snapshots to occur across the entire file system. What that means is you can now have version control every hour, every day. We can align that to backup retention periods as necessary to meet a company retention policy. And these also flow back into the end user experience so that they can see the last written files or the versions and do those recoveries themselves based upon those snapshots. Also, your admins can mount up these snapshots, recover files as necessary. On top of these user-defined definitions that all execute as a part of the metadata and capturing the differences that are occurring within the actual data payload itself, we are also, as a part of our replication process, driving snapshots every 60 seconds. That gives us an ability to rapidly recover in the event of a ransomware attack. We'll go into more detail on that in a future video, but for now, know that this can get you to within 60 seconds of the last data update has been made across the entire CloudFS global file system. So that is how we help ensure protection, security, and control while driving a new level of availability and efficiency for your end users and helping to really reduce costs by centralizing into the cloud environment. However, there's one more change, one more item that adds to this Panzura unstructured data management solution. And that's the idea of data services, or something we call PDS. Now, this also runs in the cloud and is a service that we offer. What Panzura Data Services does is takes the meta information from all of our different nodes that we have operating, and it imports all of that information into one dashboard for monitoring, for high-speed search. So you can actually search the entirety of the global file system from one location, as well as even provide an audit trail for what's occurring across this entire configuration. The power of PDS is that it allows you to start to tell the story of what's occurring across your unstructured data as you continue to grow and innovate. So ultimately, you can probably see now how we are helping customers change the game and change their thought process on what unstructured data management means and the ways that we can start to unlock that innovation for their business, the efficiency for their users, and start to transform the way they think about unstructured data in general. If you're interested, feel free to reach out to us, hit me up on LinkedIn. I'd be happy to talk more about our solutions and dive deeper into the impact that we can drive your organization. Thanks for your time.